Hi everyone, welcome. In this video, we're going to discuss about slope of a graph. So you see on the upper panel, you have the function of x, which can be drawn using these four controls that you have on the right side. So the first control allows you to plot curved graph, upward or downward curved. You can have peaks and valleys created. That is one possibility. The second control gives you to plot flat graphs. You see flat graphs, up or down you can plot it. The third control that can be used to rotate the graph. Rotate up or rotate down. Rotate up or rotate down. And then you have the other control which is used to slide it up or slide it down. So these are the four commands that we have here. And on the lower side you have the tangent. Tangent is shown in terms of a red arrow which has got both the directions, double-sided arrow. And you can keep this tangent at different positions on the graph. As it is changed its position on the graph, you see the tangent orientation is changing. Sometimes it is horizontal, sometimes it is downward sloping, and then again horizontal, and then upward sloping, and then horizontal, and so on. And also you watch here on the left side, slope of the tangent. Whenever it is horizontal, you see that the slope of the tangent would be 0. As it turns downward, it has got negative slope. And then as it turns up, you have a positive slope. Again, when it becomes horizontal, slope is 0. When downward turning, negative slope. And again 0 slope. Upward turning, positive slope. And again 0 slope. Downward turning, negative slope. And then it is 0. So you can see the orientation of the tangent on one side and also on the left hand side how the slope is changing up or down, positive or negative. So this is a general understanding of the particular simulation that we have here. So let's start with the simplest one, simplest graph. Let's focus on. On the lower panel we have the derivative function which I'll be discussing in other videos, so don't worry about it. For the time being, let's focus on the function. So the simplest command that we can use is the fourth one, where you can move the graph up or down without changing the orientation of it. No rotation here, it's a pure translation, either up or down. So suppose I keep it up there like this, and let us see the tangent. You see the tangent orientation would be always horizontal. At every position it is horizontal, and whenever the tangent is horizontal, slope is 0. Whenever the tangent is horizontal, slope is 0. So now you move the line either up or down, wherever you keep it, or up or down, or maybe on x-axis, you see that the tangent orientation is always horizontal. And whenever the tangent is horizontal, its slope is 0. So that is one. So moving the graph up or down, slope will not change. Slope of the tangent would remain the same. But let's go for the other command where the straight line can be turned up or down. So up meaning it's a counterclockwise rotation. We call it as upward sloping line. Whenever you have upward sloping line, you see that the slope is positive here. This is called upward sloping line. You see that the slope is positive, and slope is positive and constant. You see this, the tangent is moving, but it is not rotating. The orientation of the tangent is throughout constant. When the tangent orientation, in the sense when it makes the same angle with positive x-axis, slope is not going to change. Meaning for a straight line, slope is constant, and here it is positive because it is upward sloping. Now, if I turn the line downward sloping by rotating it clockwise direction from positive x-axis, so we say it is downward sloping graph, and then you see that the tangent would have a constant orientation for sure, and it is mentioned it as a negative slope. So for a straight line, slope is constant. If it is upward sloping, positive slope, constant. If it is horizontal, 0 slope and constant. If it is downward sloping, it is going to be negative slope but constant. So these are the general understanding of a straight line. Very simple. Now let's go back to the horizontal position and then start creating curves on it. So let's say upward curve and then downward curve and then upward curve, something like that. We can make one more upward curve like that. We can make it. So now let's start the tangent from origin. As it comes towards the right side, you see that the tangent is turning anti-clockwise and then it is becoming upward sloping. As it is moving upward sloping, you see the slope of the curve is increasing here. And then after that, it is going to turn down and become horizontal at the highest point. So difficult to locate the highest point. Yeah, I got it. At the highest point, you see the tangent is horizontal. So this is called local maximum. That's where the slope is 0. And this point is called critical point. Wherever the slope is 0, we call the point to be a critical point. And then it goes down, sliding down, downward sloping. Again at the bottommost point, you see the tangent would be horizontal. So whether it is the top of the peak or the bottom of the valley, you see the tangent would be horizontal. It's hard to maintain it exactly horizontally, but I think you get it. So horizontal in the sense the slope is 0 there. You can see at that point slope is 0. So at the local maxima as well as at the local minimum, slope of the tangent would be 0. And again at local maxima, you see the tangent becomes horizontal. Exactly. Alright. And again at the bottom of this valley, slope is 0 there, horizontal. Again at the top of the hill, slope is 0, tangent is horizontal. Again at the bottom of the valley. So at every bottom of the valley and at the top of every hill, you see that the slope of the tangent would be 0 because it will be oriented horizontal. So you see as the point is moved from one side to the other side, height is increasing, decreasing, that's one thing. But then whenever height increases, slope of the tangent would be upwards, positive. Whenever height is decreasing, you see the slope of the tangent is negative, downward sloping. And then it goes up and turn. Okay, so this is how we can mention the slope of the tangent. Now, let's say at this point, I move the graph up without rotation, just slide it up. Slide it up, slide it down, you see the orientation of the tangent is not changing there. The tangent is always making a fixed orientation there. Alright, meaning slope of the tangent at that point is not going to change when you move the graph up or down. Sliding of the graph without rotation along y-axis or parallel to y-axis will not change the orientation of the tangent at any point. So you can take any other position, maybe this location you consider. Now you start sliding it down, alright, slide it down or slide it up. It is moving definitely, but its orientation is not going to change. It's going to be having a fixed angle with the positive x-axis if you extend it. So slope of the tangent at any location would not be affected because of the displacement of the graph along y-axis or parallel to y-axis. So that is one important aspect. How about rotation? Let's look at the rotation part of it. If I rotate it, what is happening to orientation of the graph? Is the slope changing? You can focus over there. You see the slope is gradually decreasing. I'm rotating it and you see the slope of the tangent is continuously decreasing. It is making lesser angle or larger angle depending on how you rotate it. So the rotation of the graph will certainly change the slope. A rotation of the graph will change the graph, a slope of the graph, but translation of the graph will be having no effect on slope of the tangent. So the slope of the tangent is a very important aspect. In the next coming video, we're going to see how the slope of a tangent is related to derivative of a function. So with that, I'll close here. Thank you very much for watching. Until next time, goodbye.